Hello, greetings to everyone and welcome to this video lecture on cosmology. Through the last lectures, we studied through the mechanistic conception of Newtonian physics, that is to say, a universe grounded on its four fundamental categories of matter, space, time and motion. Afterwards, through the theory of relativity of Einstein, we came to know of a world quite different from that of the Newtonian physics. The theory of relativity changed our view of the universe in a big way as geometry of a dynamic space-time with matter-energy relative to each other in one unified view. Now the question before us is, where does this space-time matter-energy unification come from? Or how did it come to be the world? Or what is the origin of our world? Now, before going into the question of the origin of the universe, it is quite in place that we look into the historical development in scientific theories about the observable universe. We know that cosmology as science studies the universe as a whole, the heavenly bodies such as galaxies, stars and solar system, employing experimental mathematical methods. It was Claudius Ptolemy, a Greco-Egyptian astronomer, who first instituted a regular inquiry into the universe in AD 140. He propounded the geocentric theory, that is to say, the earth was the center of the universe and that the sun and other heavenly bodies revolved around the earth. This theory reigned supreme for 1400 years. After him, there came another astronomer, Nicolaus Copernicus, a Polish scientist. He overthrew the geocentric theory of Ptolemy and proposed heliocentric theory. He argued that the sun is the center of the universe and the earth is a planet revolving around the sun. Copernicus thus became the pioneer of modern astronomy, and his theory heralded a new era in the development of astronomy. But the Copernican universe was still equated with the solar system. Afterwards, in 1805, the studies conducted by the British astronomer Herschel with the help of telescope confirmed that the universe was not limited to the solar system. The solar system itself was only a part of a much vaster system of stars called the galaxy. The universe thus became quite extensive, comprising millions of stars scattered about the Milky Way, our home galaxy. Even at the beginning of 20th century, it was thought that Milky Way with its 100 billion stars represented the whole universe. As the modern cosmology began, the study of the origin and evolution of the universe in its modern form in 1920s, following Einstein's publication in 1917 of a scientific paper which described how the equations of general theory of relativity could be applied to describe the whole universe. To speak about the question of the origin of the universe, Aristotle and most of the other Greek philosophers did not like the idea of creation. So if we are to speak about creation, it takes us to something of a divine nature or divine intervention, which the Greek philosophers did not appreciate, and they did not want to get into this kind of unnecessary thinking. They held that the human race and the world around it had existed and would exist forever. From the metaphysical point of view, we usually think that causes precede their effects. It is therefore natural trying to explain the universe by appealing to the situation at earlier cosmic epochs. By the very methods of cause preceding effect, it is of very normal we try to explain our present universe by looking into the situations that were preceding the present situations. Based on it, even if the scientists could explain the present state of the universe in terms of its state a billion years ago, it would not really have achieved anything except moving the same mystery back a billion years. Otherwise, we would be wanting to explain the state a billion years ago in terms of some still earlier state, and so forth. It goes ad infinitum. And this chain of cause and effect would never end. This being the case, still our Western culture has the feeling and thinking that something must have started it all off. And there is a widespread assumption that this something that might have started it everything, or something has started it all off, cannot lie within the scope of scientific inquiry. Because the scientists, while explaining all that falls within the reach of scientific observation, at some stage in the chain of explanation, they will reach an impasse, a point beyond which they cannot penetrate with regard to the universe. Such a point is considered to be the beginning of the universe as a whole, the ultimate origin of the physical universe. Out of this inadequacy of science, naturally the question about the origin of the world seemed to belong entirely to philosophy and of religion, because reaching to an impasse where science cannot speak of the origin, it itself does not explain the origin of the universe. Naturally, the question falls within the court of philosophy and religion. In fact, scientists did not thereafter use to pay any heed to this question of the origin of the universe. They left out the question of the origin of the universe. At this state of impasse, that the scientific world taking an indifferent position with regard to the origin of the universe, there re-emerged a point of debate that existed among astrophysicists and cosmologists in 1826 concerning dark night sky, known as Olbers paradox. It is called by this name because originally it was discovered by the German astronomer Heinrich Olbers. It was popularized in 1950s by the cosmologist Hermann Bondi. The argument of the puzzle is that if the sky is dark at night, the universe we live in is dark, empty and cold. At the same time, we find also very bright and hot objects such as the sun and the stars. In that case, the sky should be bright and shining. The puzzle actually rests on the assumptions that the universe is finally or infinitely big, that it is filled with the stars more or less like the sun, and that it is eternal and unchanging. If these assumptions are taken as true, then when we look out into the universe, we ought to see stars or galaxies in every direction. The paradox consists in the fact that these assumptions lead inevitably to the conclusion that the whole sky should be bright with starlight or sunlight, but in fact the sky is dark. Now, what is the solution to the puzzle? We should know that the paradox holds true only if we admit that these three assumptions are true. That is to say, if the universe is infinite in spatial extent as well as eternal and unchanging, then light from an infinite number of stars will be pouring down upon the earth from the sky. In that case, sky could not be dark. However, the paradox can be resolved if we assume a finite age for the universe, that we are able to see only those stars whose light has had time to travel across space to the Earth since the beginning. And the three assumptions are said to be wrong. Of course, we do not know for certain whether the first assumption that the universe is infinitely big as well as infinite in extent. But we know for certain that the assumption that the universe is eternal and unchanging is false. Now, with the discoveries afterwards, it is proved that the universe is in fact changing and expanding. That is to say, some 15 billion years ago, the universe began in a big bang and is expanding, that the galaxies are moving farther apart from one another as time passes. And the reason why the sky is not bright with starlight is that the universe, which expands and evolves with the passage of time, causes a weakening of the light on its journey, dimming it. Now, redshift is a displacement of light towards at the red end of the spectrum on account of the movement of the object emitting light. This redshift theory sheds light on a certain nature of the universe, which helps the scientific world to rethink or take it up again the question of the origin of the universe. Christian Doppler discovered it, the redshift theory, in 1842. Hence, it is also called Doppler effect. What is Doppler effect? In general, Doppler effect is a change in the frequency of light or in the pitch of a sound caused by the motion of the object emitting the light or making the sound. It is familiar in everyday life through its effect on sound waves. For example, when a vehicle such as an ambulance is moving rapidly towards you with its siren sounding, the pitch you hear is higher than when the same vehicle has passed you and is moving away from you. This is because when the vehicle is moving towards you, sound waves are compressed together by its motion, that is making a higher frequency, while when it is moving away, the sound waves are stretched out, that is making a lower frequency, and the pitch is lower. Similar effect is observed with regard to light waves. The light waves from a star or a galaxy that is moving towards us are squeezed together, producing a blue shift in spectrum. And the light waves from a star that is moving away from us are stretched to longer wavelengths, producing a red shift. Thus, the movement of a star or a galaxy affects its light as seen by an observer. If the star is moving towards the observer, its light will be shifted towards the blue end of the spectrum. This is called blue shift. If the star but or galaxy is moving away from the observer, its light will be shifted to the red end of the spectrum, and which is known as the red shift. Now, measuring the distances of galaxies in the 1920s, Hubble noticed that all the galaxies except our nearest neighbors show a redshift. This indicated that the galaxies are receding from us. In 1929, he announced, that is, Edwin Hubble announced that the velocity of recession indicated by redshift as proportional to the distance of a galaxy from us. This means that the farther a galaxy is, the faster it is moving away from us. The relation between redshift and distance of the galaxies is known as Hubble's law. Thus, the Doppler shifts of galaxies, or Hubble's law, show that they are receding, the galaxies are receding, and that the universe is in a state of rapid expansion. In 1917, Einstein published a paper showing that the equations of the general theory of relativity can be applied to whole universe, and he found that the universe as a whole is expanding. Basing on Einstein's equations of the general theory of relativity, the Russian mathematician Alexander Friedman in 1922 produced two models of universe expansion and contraction. It is now generally admitted by the astronomers that the universe is in a state of rapid expansion. Modern theories about the universe are based on this state of behavior. Based on it, it is argued that there was a moment when all physical bodies were together as we could think about, or anyone could think about, a singularity. It seemed that about 15,000 million years ago, they were all at exactly the same place, as if everything at a certain moment appeared like a cosmic egg, like a point of infinite density, a point of nothingness. Here we should remember that according to Euclid, a point is that which has no parts or which has no magnitude. That is to say, galaxies and stars formed about 15 billion years ago are flying away from one another. Thereby, the universe expands into states of less density. In brief, this discovery brought back the philosophical question of the beginning of the universe into the realm of science. Thus, the question of the origin of the universe is back in the court of science. And science, now taking it very seriously, this question tries to offer an explanation about the origin within the framework of physics. Suppose if a plausible scientific theory can be constructed, then that theory will explain the origin of the universe. Then we know a scientific explanation is possible, and though it is uncertain how far it may be reliable. Thus, the scientific world took on to the most prevalent theory called the Big Bang theory. The prevalent theory regarding the origin of the universe is called the Big Bang. It was first proposed by Georges Lemaitre and Alexander Friedman in 1920s, and its modern version was developed by George Gamow in the 40s. It is now commonly held by the astronomers that the universe originated in a Big Bang some 15 billion years ago, that is some 13.7 billion years. According to this theory, the entire universe came into existence abruptly about 15 billion years ago in a gigantic explosion. It is calculated by the Big Bang that the foundation of the present universe was laid in 3 minutes 46 seconds. How is it? The Big Bang theory arrived at this conclusion by calculating and describing the earlier state of the universe from its present state based on Einstein's general theory of relativity and quantum theory. Accordingly, at first we know that the present universe is in a state of expansion, that galaxies are flying away from each other at a very high speed. From this, the scientists woke back to those earlier state of the universe when all galaxies were together in one singularity, and how to arrive at the nature of that singularity. Secondly, we know that at the end of the process of Big Bang, about 25% of the material in the universe is helium and most of the rest is hydrogen. From that point of view, the scientists worked back towards the state of the universe at the time of Big Bang singularity. Thirdly, the present state of the universe has a background temperature of at 3 Kelvin. This is known as cosmic microwave radiation or background radiation. Taking this present background radiation, the scientists are to work back to know the radiation or the temperature that existed or that triggered for the Big Bang explosion. The exact temperature of this radiation today at 3 Kelvin or minus 270 degrees Celsius. The scientists can now calculate the temperature of the earlier state of the universe at the time of the Big Bang from the present day temperature, that is 3 Kelvin. It is now generally admitted by astronomers that about 13.7 billion years ago, ETH in the universe, that is ETH is what is called a space, time, matter and energy came into existence from a point which is smaller than proton called the Big Bang singularity. We can describe by science only what happened in the universe after the time represented by singularity, sometimes called the moments of creation or the birth of the universe at time zero. So science through Big Bang is able to explain that all that happened after the time zero, but we can say that still the scientists and the scientific world are groping in darkness with regard to the situations at the time of time zero and before that. At this state, all the matter in the universe was in an extremely compressed to definite density, to an infinite density and very high temperature from which expansion is started. The materials formed out of Big Bang explosion at time zero are still traveling at the speed of thousands of kilometers per second. The temperature at which the Big Bang occurred can be or is calculated 1000 billion Kelvin and the time was 0.001 second, that is after time zero. From there onwards, let us now look into the various stages of the Big Bang explosion that took place and what happened and how things evolved to the present day development of the universe. Now, after the appearance of a singularity at the time 0.001 and the temperature of 1000 billion Kelvin, there was a constant interaction and conversion of energy and material particles. Particles like a proton and its antiparticles, antiproton, electron and its antiparticle called positron, neutron were produced out of radiation or energy. These were continuously converted into radiation or energy through the process of mutual annihilation in accordance to Einstein's equation for mass energy conversion, that is E is equal to mc square. Thus, when a particle meets its antiparticle, both are annihilated, converting themselves into energy out of which they were produced. Moreover, at such high temperature, neutrinos, or that is particles which has no electric charge and very little mass, they possessed a very high energy. They constantly interacted with the protons, converting them into neutrons, and again interacting with the neutrons, converting them into protons. Thus, at a high temperature after the Big Bang, the radiation was constantly converted into material particles, which were converted into radiation or energy through mutual destruction. At time 0.01 second, that is 100th of a second of time zero, with the temperature down to 100 billion Kelvin, matter energy conversions got slowed down. That is to say, the protons and neutrons were no longer produced out of radiation. At this stage, only the electron-positron pairs still interacted with radiation. Initially, there was the same number of neutrons as there were protons. But neutrons, unlike protons, are unstable particles, and left to themselves, they will decompose or decay themselves into electrons and protons. Decay was very fast at the high Big Bang temperature. Besides, in the Big Bang explosion, neutrinos and antineutrinos were created in abundance, and they played the role of keeping them in proportion, the production of protons and neutrons at the end of the Big Bang process. At this stage of Big Bang, protons and neutrons were subjected to constant bombardment by the neutrinos and antineutrinos. An antineutrino colliding with a proton produces positron and a neutron, while a neutrino colliding with a neutron produces an electron and a proton. And both of these reactions can run in either direction. When temperature fell to 30 billion Kelvin at time 0.1 second after creation, things began to change, or things began to be different. That is to say, with less energy available to drive reactions due to the crucial mass difference between neutrons and protons, it became relatively difficult for neutrinos and antineutrinos to trigger the reactions that converted lighter protons into heavy neutrons. It slowed down the neutron-proton conversion and resulted to the increase in the number of protons from 50-50 ratio to 38-62 ratio. Now, by the time universe had cooled to 10 billion Kelvin, and the time is 1.1 second after the moment of creation, or time zero, the density was down to 380,000 times that of water, and the balance between protons and neutrons had shifted still further, with only 24 neutrons left for every 76 protons. And by 13.8 seconds after the moment of creation, the temperature fallen to 3 billion Kelvin. Neutron conversion had slowed down dramatically. At that time, there were only 17 neutrons left for every 83 protons in the universe. Occasionally, nuclei of deuterium means heavy hydrogen atoms. So deuterium were formed as a proton and a neutron stuck together temporarily before being knocked apart by collision with other particles. At 3.7 minutes after time zero, when the temperature fell down to 1 billion Kelvin, that is 1 billion Kelvin is equal to 70 times hotter than the temperature at the core of the sun. And at this stage, the particle reactions, which were so important a few minutes earlier, have virtually ceased, and now the universe is old enough for the natural decay of neutrons to take place. From that time onwards, in every 100 seconds, 10% of the remaining free neutrons decayed into protons spontaneously, and the proportion of neutrons is already down to about 14%. In that way, neutrons escaped from extinction because of the temperature had fallen at the right time, when the nuclei of deuterium and the helium could be formed and stuck together in spite of collision with other particles. Neutrons began to combine with the protons to form stable nuclei first of deuterium, and though these nuclei still collided with each other and with other particles, due to the very low temperature, the collision could not break up the nuclei. At 900 million Kelvin temperature, most of the remaining neutrons were locked up in the nuclei of helium, each of which contains 2 neutrons and 2 protons, and the time was 3 minutes 46 seconds after time 0. The proportion of helium formed in this way was 33% of the total material produced in the Big Bang process, and most of the rest of nuclei were lone protons and hydrogen nuclei with some lighter elements. Thus, in 3 minutes 46 seconds after time 0, cosmogenesis, or the origin of the universe, was complete and necessary foundations were laid. Now, having explained the process of Big Bang through which the universe is explained to have originated, but still there are questions remaining regarding the very process and the time 0 and before that, how the situation which are still remain unexplained. And we will see the next lesson after this, how about the leftover matter and how from the foundation laid of the universe in 3 minutes 46 seconds, how the universe that we experience today is said to be developed. And we will see that in the next lesson. Thank you.